meeting of the ACT section of RINA, and we welcome you to it. Tonight's presentation will be given to us by Captains Andrew and Cliff Beazley from Port Ash. Port Ash is a manned ship model training facility for teaching all aspects of ship handling with and without tug assistance. Our clientele being pilots, masters, ship's officers, and military bridge teams, CO, XO, from major warships. So this evening's presentation will predominantly be given by Andrew, but both Andrew and Cliff will answer questions at the end. Cliff is the Managing Director of Port Ash, the Training Director and Chief Instructor, and he's been in the facility, at least according to LinkedIn, since January 2000. Andrew, his son, is the General Manager. He joined Port Ash in July 2014, having spent the previous 7 years as a marine pilot in Newcastle, and he rose from cadet to master in Howard Smith Shipping between 1983 to 1997. He sailed in a range of vessels. I'm not going to steal any of his particular thunder or his later career in as a pilot and as a Czech pilot out of Newcastle. So I'll hand the conch to Andrew. We look forward very much to your presentation, and we welcome those who have joined the meeting this evening. If I could just ask, I guess standard practice with this, if we can just be muted while the presentation is being given, and then we'll invite through the question period you to unmute and post your question. You also have the opportunity in the chat to raise a question if you'd like me to ask it on your behalf. Over to you, Andrew. Thank you.
All right, thank you very much, Warren, and good evening to all from myself and Cliff as well. I'll just activate my little share screen to get into my presentation here. And away we go with the presentation. Okay,
we can see that, so that's fine.
All right, what I'm going to do initially, for those who haven't seen it previously on our website, we do have a promotional video, and I'll just start tonight's presentation with this video. There's a lot of good information contained in it.
If ship handling is concerned, experience is gained by countless hours of training, watching, learning, feeling how subtle variances can change the movement and attitude of a ship. What if there was a way to get a real feel for the way ships behave in a real-world environment? What if there was a way to compress the hands-on training component? Welcome to Port Ash, a purpose-built facility providing world-leading training for ship's masters, officers, marine pilots, and naval officers. Located just 2 hours north of Sydney lies the state-of-the-art training facility, an easy drive to Newcastle, the second largest city in New South Wales, and the spectacular Hunter Valley region. Built to provide real-feel, real-world hands-on training with an emphasis on the practical aspects of the ship control at low speeds in a range of environments, including open, confined, and shallow water, with and without tug assistance. Utilising manned ship models, training takes place within a 2-hectare, 5-acre purpose-built lake, where hands-on training is gained under the watchful eye of experienced marine pilots. The ships have been designed to behave as full-size ships, experiencing squat, interaction, shallow water, and bank effects. Manoeuvring is impacted by natural wind and artificially generated currents, providing participants with real-world hands-on training in a real-world environment. This provides a unique opportunity and location where manoeuvres can be repeatedly practiced. Time compression means 1 hour of ship handling can be achieved in 12 minutes. What takes days to experience in port operations can be completed within hours in the safe, purpose-built environment at Port Ash, and then simply be repeated again and again, providing hands-on experience and working knowledge. The Port Ash lake system itself was designed at a scale of 25:1, featuring deep and shallow water areas. The system was constructed to recreate the scale depths of water when approaching a typical harbour environment, along with water depths within a typical harbour. With 1/3 of the lake simulating deep water at 50 metres, another third is medium depth of 25 metres, and the remainder dedicated to shallow water areas with a scale depth of 14 metres. The Port Ash facility has 32 berths of both open and sheet pile type, which provide a range of hydrodynamic effects along with 2 single-point moorings. Current is generated in the canal or open water shallow areas, so that cross-current effects can be experienced and berthing repeatedly practiced under these conditions. Extensive design and development went into the creation of the world-class facilities at Port Ash, and the same attention to detail has been applied to equipment. State-of-the-art touchscreens with virtual instrumentation and controls provide the ability to manoeuvre and orientate each vessel. The ship control system also enables power and rudder settings of specific ships to be configured. The current fleet includes Handysize, Handymax, Panamax, multi-purpose and 2 azimuth drive ships, including the larger Salt, fitted with twin azimuth drive systems and twin bow thrusters, as utilised by the Royal Australian Navy for LHD training. Port Ash provides participants with leading-edge training that blends theory and practical exercises on the purpose-built lake. The result is a world-leading facility that ensures that the knowledge gained during the course is applied to maximise learning outcomes and the overall ship handling experience.
All right, so just to continue on, as you can see in the video there, the video is showing 6 ship models, and we are actually currently at 7. Unfortunately, in that video, it doesn't show the DDG model that was added to the fleet in the last couple of years, the Hobart class DDG model. So we're actually now at 7 ship models, with number 8, the supply class AOR model, recently delivered as of Monday of last week, and which is currently being fitted out on site. So with particular reference to, I guess, the facility, it's one of 7 manned ship model centres in the world. We're fairly unique in being the only one in the Southern Hemisphere. 2 of them being located in the US of A. The most recently constructed one being built by the Panama Canal Authority for training of Panama Canal pilots a few years back when the Panama Canal was upgraded. There are 3 other centres in Europe, one of which, the one in Poland, I was lucky enough to actually participate in a course there back in 1997. It was actually just before I came ashore as a Newcastle pilot and started my 17-year tenure as a pilot in Newcastle. So one centre being located in Europe, being located in France. The other one, as I mentioned, in Poland, that I got to visit back in the late 90s, and also the facility in the UK as well. I think we're fairly unique in respect of Port Ash. It's privately owned, currently fully owned by Cliff. It's been a family business, I guess, from day one. When we started building, in that image you can see on your screen there, we started building the very first ship model, which you can see second from the right there in that image, the model of Triton, which was actually a scale model at 25:1 scale that we built originally from drawings, general arrangement and lines plans of the Ampol TVA, as the vessel was originally known as when it was on the Australian coast. The one to the left, the Mentor, you can see there, the tugs attached as well. That was the second ship model that followed very soon after Port Ash kicked off on operations on site at 12 Mile Creek there back in around 2000. So Cliff ran the first course back in 2001 with a single pilot from Darwin, actually, using those two ship models that you see in the centre of the screen. And for those who aren't familiar with our location, we're around about a 30-minute drive north of Newcastle, straight up the Pacific Highway, just on the left-hand side there, just north of Raymond Terrace. So located very centrally near Newcastle Airport and just to the north of the Port of Newcastle. I guess to look at man model training, well, what is it? It's, I guess, another form of simulation rather than generating a mathematical electronic model, which, you know, we've certainly seen, and I've witnessed myself, simulators come online in Australia, I guess, since probably the mid-80s. We first saw the first four-mission bridge simulator, or what it was then, back in 1984. I remember down at the Australian Maritime College. I was actually down there as a cadet then when they were initially introducing the simulator down there. And when I look at, you know, where the simulators, how they developed over the decades now, it's quite incredible, I guess, to see the level of detail that electronic simulations achieve, especially once you start integrating tug operations with a full mission bridge simulator and the accuracy you can generate there. The manned ship models commenced, I guess, with the original centre located in France. That's Port Revel back in the late 60s. One of the oil majors started with the centre there, and then since then, as I mentioned before, we've seen up to 7 centres now being developed and operational worldwide. And the man model training side of it uses the accurately scaled ship models combined with an accurately scaled lake facility. And there are some facilities, and we're one of probably a handful, where the actual lake facility has been custom built. It's not just part of an existing waterway. In this case, Cliff very carefully designed, I guess, what is the approaches to a port and also the confined waterways associated with a generic port to give us the level of simulation that we can get at Port Ash with our scale channels and shallow water areas, which all combine, along with the scale tug models that you can see in that second image on this particular slide, all combines to create the ship handling environment that we have at Port Ash. Just as an overview of the lake facility itself, which I guess was also explained in that video, the lake itself, all the facilities are all constructed generally at a scale of 25:1 scale. There are, as the video mentioned there are a number of varieties of different types of berth, both your sheet pile style hard face wharf, where we see different hydrodynamic characteristics occurring compared to, say, our dolphin style berths. You've got the 120 metre wide channel coming up from the lighthouse shown in the video around our half nautical mile horseshoe or radius horseshoe bend. So I guess any Newcastle or ex-Newcastle pilot who builds a man model training centre must have their own replica of the horseshoe bend incorporated into it. And you can see there coming up into our other basin area there where we have other areas and the approaches to the boat shed. So a lot of infrastructure, I guess, is something that we've developed over the last couple of decades of operation. The shed complex you see there now is 3 times the original size that it was when Cliff ran the first course back in 2001. The training room now being double the size, and with demand, I'd like to say that into the future we'll see a lot of the infrastructure there probably slowly increase in size as well to cater with demand. The lake facility itself, really it's a fairly shallow lake, which does provide some challenges in terms of maintaining the quality of the bottom and the water quality. You see there, we actually only have a lake here that's only 2 metres deep. So it's not a terribly deep lake, and the bulk of the lake was actually designed by Cliff and sculpted very carefully to replicate a lot of shallow water areas. So in a lot of the other areas there, the Channel Basin area, the Anchor Bay area shown on the chart there, we're only talking real water depths there of 600 to 800 millimetres. It's quite shallow. And you can see there as well how the overall facility incorporates an open water section of water, plus all the intricacies of operating in the channel and other berthing areas as well, which you'll see further images as we go along. Just a quick look at our older style Potash, I guess, paper chart, if you'd like to call it that. We also, as you'll see shortly, we also have a level 6 E&C of the Potash Lake as well, thanks to the hydrographic department. And just moving on now to the value, I guess, of manned models in ship handling training. We've seen for many years how manned models have been used for ship handling training in this real world environment. So rather than use a simulated electronic environment, we're actually out in the, I guess, in the real world. This time what we've done is scale down the physical size of everything. I guess the primary focus of why this training medium still exists all these years and decades later is its primary focus on the technical skill of visual ship handling. So I guess when you look at how electronic simulation and manned models complement one another, certainly we see where the electronic simulators are very, very good for, I guess, a lot of the electronic navigation and integration of visual ship handling, whereas I guess the manned models, we tend to focus far more on visual ship handling and developing visual ship handling techniques in the ship handler and trying to maintain those skills as well. So as it mentions there on the slide, both simulator mediums, that's manned model and electronic simulation, they have their own individual strengths. And what we see in most training regimes for ports, pilotage, service providers, and also we've seen increasingly with the navies of the Royal Australian Navy and the Royal New Zealand Navy, we've seen an increased focus on combining both methods of training for ship handling operations. I guess the main strength of the manned model, as I'll elaborate further shortly, it brings the theory of your ship handling textbook to life in a very powerful way. It really does. The actual physical concepts of handling a vessel in the real world environment are very effectively demonstrated, especially in situations like you're seeing in those images there, where on a Wednesday, the part of our 5-day course in general ship handling, we focus heavily on examining hydrodynamic effects. And in this particular exercise you're viewing there of 2 vessels actually passing in a 120 metre wide narrow channel. So as I always start off the exercise by saying to the combatants, we don't like to advise that this sort of thing's done under these sort of risk management parameters. It's a very narrow channel in this instance, but it's also of great learning value to see how 2 vessels, when they approach one another and are in such close proximity to each other, how the vessel's behaviour changes and how the interaction between both vessels is very effectively demonstrated with this training medium. And you can see in this canal as well, not only are the models interacting with one another, we also get an excellent demonstration too. Once the vessels move to the sides of the channel, we see a great deal of bank suction coming into play, etc. Other sides of the training medium that really bring theory to life are also examining, as we do on a Tuesday with our 5-day course in general ship handling, looking at how the effects of wind and current, in other words, forces above the waterline of the vessel and also below the waterline of the vessel, how they affect the vessel, and also going through in great detail a lot of theory on how to best handle vessels and gain control of vessels when they're exposed to such forces, and also being able to put that theory into effect when we go out on the water and practice it on the models. Once we do get out on the water, as you can see there, one of the things with man model simulation is we're operating in a compressed time frame. So at 25:1 scale, 5 being the square root of the scale, we're actually operating in a time frame compressed by a factor of 5. So in reality, we're out there for 1 hour of training. In that time, we've actually done 5 hours of ship handling. So it's a very cost-effective means of being able to get out on the water, take a vessel off a berth, transit a channel, conduct a berthing operation or observing bank suction, shallow water effects, and then conduct another berthing, then unberth the vessel, proceed around to another area, say for instance, conduct a turn in deep or shallow water, and then proceed back to a wharf. So typically most of the exercises, we structure the runs around about 1 hour duration, because what you achieve in that hour equates to 5 hours of ship handling. So it's actually a very intense learning time frame out there in the water for that 1 hour when you have the kind of one of these models. Just to further talk about the uniqueness of the channel at Port Ash, you can see here in this video, you can see our level 6 EMC of the Port Ash Lake and the Horseshoe Bend here. And what we're observing here is the older Panamax style, as I like to call it, model of the Mentor, around about a 230 metre long model of a typical bulk carrier of that size, transiting around the Horseshoe. And you can just observe here as the model's being tracked in the channel using a PPU that I actually used to use, and very similar to what I used to use in real life as a Newcastle pilot. And you can see here the model transiting down a 120 metre wide channel, which you've seen visually. And you can see how the model's shearing around in the channel, suffering bank suction, shearing across to the other side of the channel as it's doing. So you can see there all of the intricacies of how these models are affected by bank suction. And during this particular exercise, as the model exits past Plover Point here, which you can see on the port-hand side of the vessel, you'll see a massive amount of bank suction and the vessel actually shears off to starboard. And with too late a correction, it'll actually ground on this shallow water patch over here. So once again as well, we have the ability, if needs be, to track models to a reasonable level of accuracy and then debrief a scenario, such as the one you're seeing here, which once again is of great value when training, especially demonstrating a lot of these intricacies of ship handling in confined waters. And just to elaborate further on that, when we talk about vessel performance in the deep water section of the lake, you can see here now the same model. And I guess this to me is one of the most, it's one of the stronger bits of textbook theory coming to life in the man model training environment. You can see here where Mentor is being turned through 360 degrees in deep water at full sea speed, and the vessel's rotating around, and instantly we can very quickly see the advanced transfer tactical diameter of this turn in deep water and how the vessel's actually performing in water that's around about, as it shows there, somewhere around the 50 metre deep scale depth. And then as we come across now, the model will transit across into the shallower area of the lake to the north of where it's currently located. And typically then it'll drop down into water depths, say of around about 14 metres, perhaps 12 metres, perhaps even shallower than that, as some of the soundings are indicating. So we'll see the underkeel clearance reducing dramatically. And what the actual training participant sees are all the things we'd expect a real vessel to demonstrate. It becomes very sluggish to handle. It's very difficult to turn. The speed's reduced. So for the same power input, we're seeing perhaps a 1/3 reduction in the vessel's speed, perhaps slightly more than that. And most importantly, we've talked about already in the training room before doing this exercise, we've already talked about the theory of how our tactical diameter of our turning circles being doubled due to the shallow water effects. And you can see quite clearly there how the arc of that turn that's being tracked there is pretty much exactly double of that original turn. And as Mentor continues around in its 360-degree turn there, you can see all of the theory coming to life, including this last section as the models run into slightly deeper water where the turn is now actually tightening up, and we're seeing a reduction in the continuous turning circle tactical diameter. So once again, you can see where all of the theory side of it really does come to life once the participant sitting in the model, usually in the conning position down aft on this particular model, or it could be a model of a warship where the conning position is forward, and they get to actually experience all of these things, and then you have the ability to debrief it and look at it later on. All right. We see man model training still heavily used in the commercial shipping industry and in ports for, I guess, general ship handling training, and mainly focusing on the skill of visual ship handling for your merchant navy deck officers and masters. As I mentioned earlier in the presentation, I was lucky enough to go to one of the European centres as an Australian master many years ago, and it's to me, this sort of training really does help you in the early days of developing your ship handling skills. We've also seen over the last few decades, at times, pilot organisations or pilotage service providers, port authorities, using the training medium of man models, or the simulation medium of man models, for evaluating potential pilot candidates for entry into marine pilot training programs. It doesn't take long once somebody becomes used to the scale effects of man models. It becomes very, very clear, how people, I guess, how their spatial awareness and other factors, I guess, display themselves when they're put in the conning position on a man model under a simulated environment. And we also see, whoops, sorry, I jumped the slide there. We also see where the initial training of a new pilot in any port in this area of visual ship handling being recommended by the IMO in their resolution 0960. So, which you'll see there now on your screen there, training and certification or licensing standards. And down the bottom there, it mentions both computer and man model classroom instruction or other training methods being recommended for the licensing and certification of maritime pilots other than deep sea pilots. There's a further reference to the IMO resolution 0960 coming up shortly, after we also look at how we've seen in recent times pilotage service providers and ports using man model training in conjunction with simulator training for marine pilot continuous professional development training, mainly in the areas of, I guess, emergency scenario training. So During my career, we saw in pilotage 17 years in the Port of Newcastle, we saw an increasing emphasis on risk analysing the pilotage, looking at how and identifying each risk involved with each stage of the pilotage, and looking then at how we go about putting in procedures and also processes to mitigate against such risk. And then more importantly, in incorporating that in your training regime, not only for new entry pilots, but also increasingly introducing it into your ongoing CPD for your licensed pilots at regular intervals. And you see there as well a reference to it in a minute from the IMO in A960 again for ongoing skills maintenance for marine pilots. And I guess with the CPD training, what we like to do, especially when it comes to pilots, is refresh, I guess, basic knowledge of ship handling principles. What we've seen, I guess, in recent years is a tendency for new ship handlers to join a pilotage area or a port operation as a pilot, where they'll initially undertake or have already completed the full general ship handling course of 5 days. So during that, they've learned all of these basic principles of ship handling. They've seen all of the effects of shallow water on a vessel and vessel interaction. So what we see then is at regular intervals, pilots returning just to very briefly refresh themselves with some of these principles, but mainly focusing on use of other forms of controlling a vessel when it's suffered perhaps a propulsion or a rudder failure. And usually that involves the use of anchors, perhaps in emergency scenarios, if that's appropriate, or more likely to involve the use of tugs during emergency scenarios. And we also see with the azimuth drive ship models that we have at Port Ash, the 2 Azipod models that we have, an opportunity there to refresh some basic skills in how we go about manoeuvring vessels with azimuth drive propulsion systems as well. Once again, with regard CPD for licensed marine pilots, we see an A960, again a reference to it at 0.6 down the bottom of your screen there, courses in ship handling training centres using man models being part of what a competent pilotage authority is encouraged to provide in maintaining skills for certified and licensed pilots to maintain their proficiency. What we also see now as well, and I guess with Port Ash has had quite a long-standing relationship now with the Royal Australian Navy. As you can see, a lot of the images that I've shown so far, nearly half the fleet is grey in colour, so that gives you a good idea of the strength of the relationship between Port Ash and the Royal Australian Navy, and also in more recent years the Royal New Zealand Navy. And what we've seen with regards to the Royal Australian Navy, we've seen ship handling training using man models basically integrated into training regimes for the navigating officers at 3 stages. It's only something that's happened very recently, where we've now seen man models introduced during a 3-day training course for our intermediate navigators. So the minor warfare vessels that these intermediate navigators go on to, they complete an INWOC course, usually of 3 days duration at Port Ash. Some of them may have already attended Port Ash as part of a vessel's bridge team. So we do see that from time to time. But in general, that level now for navigators is where we see people start off at. And then it used to be they'd come and do a full 5-day course, which was based on our 5-day course in general ship handling at the surface combatant navigation course level. That, as I've just mentioned, it's only about 12 months we've seen the INWOC course starting doing short courses. So at the second stage there at SCNC level, we see the navigators for our major fleet units, mainly frigates and the destroyers, the Anzac class frigates and the Hobart class destroyers. We see those navigators come through doing the 5-day course in general ship handling, which looks at all of the ship handling characteristics in confined waters. And then what we then see happen at a later date, usually say roughly a 2 to 3 year interval later, we'll see them come back as a principal warfare officer navigation plus course, PYN plus as it's called, coming back to do the deep draft 5-day man model course. And generally these navigators will then go on to join one of the AORs or perhaps HMAS Chills, the LSD vessel of the RAN fleet, or the one of the 2 LHDs, HMAS Canberra or HMAS Adelaide. So what we also have the ability to do with our very mixed fleet at Port Ash now is to focus heavily at this level on what platform people are going to, and also at SCNC level, and focus heavily on what is appropriate platform for them to be, I guess, experiencing before they then go on to complete the rest of their training on simulators and then proceed to their respective vessels with their postings. We also see the command navigation course for executive officers and commanding officers, usually prior to them being posted to their respective vessels. Once again, that course is a 5-day course based on the course in general ship handling. And that really covers pretty much everything, you know, from ship handling characteristics, basic ship handling principles, hydrodynamics, and the last 2 days generally focusing heavily on tug operations handling the vessel, or focusing on the platform, a combination of tug operations and also on the intricacies of the vessel involved. So in the case of the Hobart class DDGs, for those who aren't familiar with it, a twin screw vessel with twin rudder configuration. It's equipped, the real vessels are equipped with an azimuthing style bow thruster, which can be vectored through a 360-degree arc, which is a retractable azimuthing bow thruster. And the model that you see in that top left-hand image there has all of the same characteristics. The bow thruster unit itself is pretty much exactly right down to the control box, and the controls, the scale replica of the real thing. So a lot of the time people come from the real ship with bridge teams. As you'll see there, there's also specific vessel type training for naval officers that we see conducted by individual ships. So we'll see people come off the ships. One of the great things now about having, say, for instance, the APU controls identical to what they have on the real vessel is they can switch from real life to the simulated model, the same as what you do in a simulator, with a great deal of ease and also familiarity. The second image there you see on that slide there is of the Centurion model. Centurion is actually the 3rd oldest model that we have in the Port Ash fleet. Cliff designed it originally as being a very multi-purpose vessel, and you'll see that as advertised on our website. It actually has 3 propeller shafts and 3 rudder stocks incorporated into it, and a tunnel style bow thruster. So this model was initially meant for replicating either a single screw vessel with a single rudder, or it could be single screw with twin rudders, or it can be swapped over to twin screw, and it could be inward turning, outward turning propellers with either a single rudder, which is what we do for the Anzac configuration, as you can see in that image there. But it also could be rigged as a twin screw, twin rudder vessel for typically what we use for our INWOC course for our intermediate navigators who perhaps are proceeding to patrol boats. So yeah, Centurion, probably one of the most flexible models that we have in the fleet. And yeah, you're seeing her there in that image after her major midlife refit where it was upgraded. We don't generally use the centre shaft anymore. It used to be heavily used for the FFG simulation when we had the FFG class in the Navy, but now it's mainly spending its life these days rigged as either an Anzac class frigate or a twin screw, twin rudder vessel for patrol boat simulation. All of our models, as it mentioned in the video, are controlled by a touchscreen, which is, I guess, generic in terms of a standard arrangement in terms of a bridge telegraph. You can see there a press button arrangement for rudder selection. What you're seeing there actually has been upgraded further as actually a new system we're trialling at the moment, which is slightly different to what you're seeing there. But one of the things that I was quite keen when I came on board 7 years ago was to try and take some of the things that could be done, say, an electronic simulator where you can fail things in the control room of the simulator and induce failures during an emergency scenario, and now we can do that with our manned models as well. So you can see there that top left-hand panel there where I can input a main engine failure, I can lock it, I can introduce rudder failures. So once again, all of these sorts of failures are very powerful things when we're conducting CPD training. And coming back to the Navy training, we see a focus on this at the PON plus level as well. And you can see there as well in that top section there where I can fail and lock bow thruster and stern thrusters. And probably the most insidious one of the lot is to simulate what happens when your helmsman puts the rudder the wrong way, which being an ex-Newcastle pilot is something we always heavily focused on because of the narrowness of the channel and the size of the vessels. A wrong way rudder order was something that was could turn into a major issue. So once again, something here that's simulated, whereby the conning officer asks for the rudder to be put in a certain position. The helmsman inadvertently puts the rudder the wrong way, and then it's corrected by the process of going through a midship order before the system, in this case, resets itself so that we can accurately simulate these sorts of scenarios. Once again, it has its place too when we're conducting Navy bridge team or navigator training, where we make sure we also introduce that as well into the training regime. The images here are showing the largest model that we've got on the Port Ash fleet, constructed for the RAN, I think around 6 years ago. Cliff can correct me if I'm wrong there with the numbers, probably a bit like, she's probably longer than that now, probably eight years ago. And you can see the top left-hand image of the LHD model named Assault. So it was a scale model built of the HMAS Canberra, HMAS Adelaide. And you can see there the sort of level that we've gone to simulate not only the Azipod combi lever controls, plus the display as well, but also as well on the left-hand side there, we can actually switch this model into a C mode where both Azipods are synchronized together and steered. So once again, you can simulate, and to a large degree, we've done the same thing with the DDG model. We can show a lot of the actual specific, I guess, propulsion systems and steering systems of a vessel and simulate that in this scale environment. If you take off the ski jump ramp, as you can see there in the image on the right-hand side, and you put all the additional casing on to increase the windage, then we can then reconfigure this model as a 289-metre cruise ship. That's exactly the same hull as you can see there, with its twin bow thrusters and twin Azipods. It's quite a good replica of a modern-day 289-metre azimuth drive cruise vessel. And the windage is certainly very similar to what we see on the real size vessel. So I guess just to start to wind the presentation side of things up before questions. Why use man models for ship handling training? Well, as I mentioned already, both mediums, I guess, form part of the building blocks of any training regime to build to put a ship handler together, I guess, whether they're a merchant navy deck officer, where we want to give them some basic understanding and give them the skills required to be able to participate in a bridge team to a higher level of proficiency, and also masters as well. It was very much the case, I guess, in the early days. I remember coming through the training systems in our country where there was very little emphasis on this, and literally you're faced with either being the senior officer on a bridge as a chief officer or a master with not terribly much understanding of all of this sort of thing. So it's to me, it's a real credit to the maritime industry that it has changed its training regime in that respect. Combining it with electronic simulation, we see both training methods cover all of the aspects of ship handling training for marine pilot training in terms of visual ship handling skills. All right. And the ongoing CPD for marine pilots, as well as I've previously mentioned with that IMO resolution A960, reflecting what's required for basic training of pilots and also for ongoing training of pilotage or ship handling skills for pilots. And I guess the same applies for naval ship handlers as well. You can see there from my previous mention there, it's quite heavily integrated now into the RAN's training regime at 3 levels. But we also see an increasing enthusiasm for ships to return at a later date and conduct perhaps 1, 2, 3 day training courses. And one of the great things that certainly myself and Cliff have observed in recent years is how a lot of the captains and executive officers and the navigators have actively sought to bring quite junior members of their bridge teams along and let them be introduced in this training medium to ship handling and the concepts of it in confined waterways, which I think is a very, very powerful thing. And I think from my observation, it's very good to see that happening at an early level for people who stand watch on the bridge of a vessel. And then certainly we see how the man models provide a realistic hydrodynamic effect in the real world environment, as it mentions there, and really enable the ship handler to feel what's going on. In a simulator, yes, the simulators these days, and we're even looking these days at some of the virtual reality type scenarios, generally with a 2-dimensional electronic screen, you don't get that depth perception that you do get in real life, which is one of the strengths of the man model training medium. You can see there in that bottom image there, a finish to the day of Mentor, our 230-metre Panamax vessel that you saw zigzagging down the channel earlier on, conducting a swing stern to its berth with a tug taking the stern around to port. And the top image there on that slide being a trainee from the Royal Australian Navy in the LSD model, a model of HMAS Jules that was constructed some years ago, conducting some basic ASIPOD training under supervision there. And you can see there a whole line of vessels entering the channel there, which was this particular shot was taken after we'd completed the video shoot of the vessels on the lake, which you saw at the start of the presentation. So on that note, I'll wrap things up and open things up for questions.